Okay, so let's get started with um well, time flies, it's October already. So let's get started with WasmEdge community meeting. And we have 3 items in the agenda. So we'll get started with Haidai about the newly released WasmEdge 0.14.1 and what we can look forward to for the 0.15.0. So Haidai, please.
Okay, great. So I'm doing the 40.1 review. And so let's go into the highlight. And this version, I believe, the most of the important thing is that we update and support lots of the WAS neural network backends. And we also support the WAS related SIMD proposal. So if you are interested to use this new SIMD instruction to accelerate your program, you can try to enable it and try it. I believe, it will bring some of the uh, performance improvements if you are using the new RxMD proposal. And we also have support the instantiation for the component model proposal. So I believe the loader, the instantiation already implemented in the WasmEdge. So it provide the fundamental things that we can continue to do the execution phase and start section and more, component model related features in the future version. So this is, very important step for the component model. And also, after this release, the WASI login plugin will be a built-in plugin, which means you don't have to, install it uh, as a standalone plugin. It just built in, so you can, you can use the WASI login just directly like how you use WASI. Yeah. And we support a new distro actually in our next version 0.15. We will start release some new essays based on these new distros, which is the Manineers 1028, and it will be based on the Elba Linux 8 or CentOS 8 if you are familiar with CentOS. And so, let's see what's new we added in the WASI neural network backend. Basically, we always, up to date to sync up with the llama.cv project. So you can use the latest, like llama 3.2 model with our plugins. And also we support the Whisper.cpp. And now, if you are using the macOS, we have the GPU support, and we also have two, text to voice framework integrations. One is the Piper, and the other is the ChatTTS. If you are familiar with that, you can just, download the plugin and use it. And also we have, two new roster-based plugin. One is these two are different applications, but they are based on the same, roster framework called BurnIS. So if you are familiar with that and you would like to, add more application based on this framework, you can just, create a pull request or create an issue that, hey, I have an application and this application is based on this framework, and I would like to, I would like to see if our plugin can support it. We are very, welcome for the ideas. Also, one important thing is that we support the Stable Diffusion plugin. So now you can use the Stable Diffusion, including the diffusion model and the flux model, and that both support GPU on the Mac OS or Linux with CUDA. Yeah. And we also have an experimental support for the LM.C, which means you can use our plugin to train in a GPT-2 model, and just based on the LM.C project. So that's basically our highlights of the 14.1 version. And what's new if we are moved to the 15.0. And actually we will have two more WASI neural network backends. One is the MLX framework from Apple, and the other is TensorRT LM framework from NVIDIA. So with these two new backends, one you can leverage more Apple provided model, and the other one is that will allow you to run some models based on the CUDA architecture. And we figure out that if you are using the TensorRT-LM, it will bring more performance improvement. If you are using the same model, which is using the Llama.3 framework. So we believe if you are based on the CUDA architecture, you can get some benefit from this new backend. And we will provide the virtual file system support for the plugins. So I believe it will bring more secure environment for the especially Watson neural network model, because that you can find that more and more plugin which will rely on multiple models, and some of models will provided by the NM preload option. And we believe that if we can ensure that all of the models, such as the multi-model, the lava model, which will rely on one or more different models, and with this feature, it can be more secure if we load this model from the virtual file system. And also we have two new component model related features will be shipped during the 15.0. One is the stock section, and the other is the resource type. And we believe that once we have these two more fundamental features, that we can starting to merge the placeholder for the WASI Preview 2, and we are still focused on implement all of the WASI HTTP proposal relative proposals. Yeah, and the last one is that we already duplicate all of the CentOS 7 essays, so we won't have the support start from the next release. So that's all of our review and what's new in our next version. Yeah, so that's all. Thank you.
All right, thank you, Hadai. Yeah, that's so as you can see, we have a lot WASI-N or AI related stuff. So I also understand that WASI-N standard is changing over time. So maybe it will move to the next phase of the WASI standard. So one of the interesting plugins that we demoed in our last meeting was Stable Diffusion. A lot of people have talked about that and asked us about Stable Diffusion support, because that's one of the mostly widely used use case for AI, right? So over the last month, we have significantly improved model support and also performance of this particular plugin. So for our next speaker, I asked Vivian to come on and give us a demo of our latest advance of text to image generation. Vivian, please.
Can you see my terminal?
Yes.
Okay. So, as I mentioned before, we released the WasmEdge 0.14.1 last week, and one of the most exciting features is that we added Stable Diffusion plugin support. So we can run the Stable Diffusion model and also the Flux model on our own machine and generate the images. So compared with Stable Diffusion model, Flux model has better performance, but it will cost them long time. So the machines that I demoed today is my own MacBook Air. It only has 16 gigabytes. So generating generating an image on my machine will take almost 3 minutes. So I will send the API request firstly, and then go through the whole tutorial. As you can see, this is the API request to generate the image. The API server is also OpenAI compatible. So you can integrate the SD API server to any OpenAI based framework. So my prompt is a beautiful white woman dressed in a medieval costume and in the dark forest, and there will be also a sword in her hand. Let's see let's see the image generated by Flux. So I will send the API request. Here is the command line to run the Flux model. As you can see, the WasmEdge Stable Diffusion plugin start to generate the image. While we are waiting the image generation, we can go through the whole process, how to run Flux on your own machine. So I will switch to the this tutorial. This tutorial is on is published on secondstate.io /articles/flux1/ so this is link, and you can follow the article to run Flux on your own machine. So the first step is that to install the WasmEdge 0.14.1 version. Using this simple command line, and because the Stable Diffusion support is still in a very early stage, so you will need to manually install the Stable Diffusion plugin. But if you are running a text generation model like Llama model, you don't need to do that. Our installer will handle the process. So depending on your platform, on your hardware, you will need to install different Stable Diffusion plugins. So here I installed the plugin for Mac Apple chip with the mental support. It will increase the generation process. So as I mentioned before, my MacBook is with M2 chip, so generating image will cost 3 minutes. But if there is no mental, just pure CPU, it will cost about 30 minutes. And if you have CUDA and CUDA in your hand, you need to download the Stable Diffusion plugin for CUDA 12, and then unzip the plugin. There is one thing that you need to pay attention to, that is the WasmEdge plugin is not compatible with the Stable Diffusion plugin on the Mac platform. So if you are running the Flux plugin on your MacBook, you will need to execute this command line to remove the WasmEdge plugin. But for Linux, there is no conflicts between WasmEdge and the Stable Diffusion plugin. So you just need to unzip the plugin. And the next step is that to download the four models as four models, and those models have different roles. So for the main model, the FLUX.1 model is responsible for text image generation, and the AEF16 model is a VE file. It will compress and decompress the image, and the clip-L model connects the textual prompts with the image, and the T5 accessor model will process and encode the text prompts. So so we will need to download those four models, and then we will need to download the SD API server. It's also a WASM file, so you can run it across different platforms like CPU and DPUs and GPUs. If you are interested in the source code, it's also written in Rust, and we compiled it into WASM. The GitHub repo is here, and if you are interested in to check out the source code, you can go to this GitHub repo. And besides the Flux, we also can run the Stable Diffusion models. You can just follow the README on this repo. But to be honest, Flux has better image. Okay, so right now we have installed the WasmEdge and the Stable Diffusion plugin. It's the runtime for Flux model, and we also downloaded the model files, and we also have the API server program. So the next step is to start the API server. We can go back to my terminal. So as you can see, I use this command line to start running the Flux model. And the default port, the Flux model API server will run on the port 8080 port by default. You can also change it by adding the command line. So from the log, we can see that the image is already generated. From the model start to generate the image, and the entry to the image generation ends. It takes almost 2 minutes. So let's go to my let's go to check the image. Okay, here is the image generated by the Flux model. It's a beautiful white woman. It has two swords in her hands.
No, we didn't see the photo.
Yeah, I can see the image.
So you can't see the image.
I can see it.
Okay. Yeah. So this is the image generated by Flux. And in this article, we also have two image examples. And I also put the prompts in the article. And if you are interested, you can try. Okay, I think that's all. Oh, one more thing. So so because I my machine only has 16 gigabytes RAM, so I only can run GGUF format GGUF format models. But if your machine is with bigger RAM, you can run the safe tensors file model, and you can just simply replace the GGUF file name with the safe tensors file name, and then I think you will get a better image. Okay, that's all.
All right, thank you, Vivian. Yeah, that's so I thought that capability is really good, you know, and I would also add that the image generation is a lot faster on your NVIDIA GPUs. That actually shows you, although the Mac GPU has larger memory and is generally very good for large language model, but when it comes to image generation and and things like that, performance really matters. So the NVIDIA GPU could be a lot faster. Yeah, so if you have a NVIDIA GPU, you could like a 4090, you could try it, and it's going to be a lot faster. That also means, although we have an API server that you can, you can generate image like Vivian just showed, but it's not, sending an HTTP request and then get an image back in an HTTP response. It's not typically not like that, because most applications can't wait, for the HTTP response for a couple minutes. You time out by then. So so there's some infrastructure you have to build in your application so that it generates an image and then provide some kind of asynchronous alert that's to ask you to download the image after the fact, right? So that's something I think we'll continue to improve and provide those functionalities to to developers, so that it makes this type of applications easier to build. So yeah, that's so personally, I thought that was a big improvement from last month's community meeting when we demoed Stable Diffusion, just not only from the image quality but also from the speed. So we'll continue to improve that, and I think there are other ideas that we are experimenting with, and other frameworks that claim to generate images a lot faster. So so there's so stay tuned. There's I think we have a lot of conversations that's with people in the community, and so hopefully we'll have something else to demo in the next community meeting. So yeah, so those are very good. And then I think our next talk is also a demo, right? So because it's really late in Asia, so I don't think George is here in this meeting, but I believe he made a recording, right? So it's one of the other model or plugins that people have always asked for, which is not text to image, but text to voice, so the TTS plugin. And so Vivian, would you be able to demo this for George, or
Oh, yes, George has recorded a video for us, so I will play the video.
Okay,
And
that's excellent.
yeah, while we have so many demos in the community, because we just released our new version. We want to show the new version.
Okay.
Okay, can you see my screen?
Yes.
Hi, I'm Cao Hanwen. Today I will introduce the WasmEdge plugin, ChatTTS backend. This is today's outline. In the first, we will introduce the ChatTTS. Next, we will introduce how to install dependencies and build WasmEdge. Finally, we will run an example and show more options for advanced use of ChatTTS. This is the WasmEdge example repo. You can find many examples of the WasmEdge plugin backend in this repo. It also includes ChatTTS backend. All the tutorial and example code you can find in the repo. ChatTTS is a text-to-speech model designed specifically for dialogue scenarios, such as an assistant. ChatTTS backend is the one of WasmEdge plugin backend. It depends on ChatTTS to develop a backend following WasmEdge API that can generate speech from text, like other WasmEdge plugin backend. ChatTTS also follows WasmEdge API. If you have used other WasmEdge plugins, you may get started quickly. Before start demo, we need to install some dependencies. Because ChatTTS is developed by Python, we will use Python C++ API in our backend. Then we recommended using pip to install ChatTTS. If you have another version required, you can adjust by yourself. Or if you want to use other accelerated library, you can install them together in the step. The next step is to install WasmEdge. In the first, you need to clone WasmEdge and change the directory to the source folder. Use the following cmake command to configure a project. In order to install ChatTTS, you need to set ChatTTS as WasmEdge plugin WasmEdge backend value, and build and install WasmEdge. The next step is to build our example code to Wasm. Use cargo build to build Wasm and run WasmEdge to run the Wasm. Our ChatTTS provides 6 API. The load API is to load Python ChatTTS and init a graph. Init execution context is to create a context. Set input is used to pass the input prompt to context and set configuration. Then use the compute function to generate the sound. Use get output to get the audio array from the backend. When you want to start the ChatTTS backend, you can use unload to release the Python resource. After you call unload, if you want to use ChatTTS again, you need to call load function. Otherwise, you cannot use other functions. It is our example code. We set a prompt to it is a text sentence for ChatTTS, and we want to change it to audio. We will ignore UV black for now. It is a special token, which we will introduce later. Then convert the string to byte array. Next, we use load to create a graph. Because ChatTTS will auto download the model and the load, so we just pass an empty array to the backend. Next, we call init execution context to create context, and the code set input to pass our prompt and use compute to generate a result. Finally, we use output get output to get the array audio array. We use a RAS audio library to the audio array change the audio array to WAV file. Then let's start a quick demo. In the first, we use cargo build to build the Wasm. Then we use WasmEdge to run the Watson. You can see that because our computer only have CPU, so it use CPU. Then it start to generate the audio. You can see that it generates a web file named output1.web. Because it is a remote computer, I cannot directly play the audio. So I play a result I generate before the demo.
It's a test sentence for ChatTTS.
Then let me talk about the control token. In the first, we play original sound.
This test sentence for just ChatTTS.
If we interrupt at the beginning of the sentence, it sounds like this.
It is test sentence for just ChatTTS.
You can hear him loud at the beginning and start saying. And if we insert UV break between sentence and the forward,
it is test sentence for just ChatTTS.
You can hear it has a small break. How about we change UV break to L break?
It is test sentence for ChatTTS.
You can hear it has a noticeable pause in the middle of the sentence. So you can use the control token to let your generated sound have more emotion. Next, we have more advanced option you can set. You just use the set input function and set the index to 1. There are 5 options you can set. The first one is pump, which will generate a special token in the text to synthesis. The special the use case you can refer the example code. Next is SPKEMB. It is a sample speaker. You can use it to add a sample speaker. If you pass a random as the value, it will randomly generate a speaker. The next 3 is temperature, top K, and the top P. It is the parameter for generating and the sampling process. You can adjust it for what you want. Then it is all the demo. Thank you for your listen.
All right. Yeah. So, yeah, this is this plugin is already ready. So if you are interested in using OpenAI like text to voice, adding this capability to your application, you should be able to use that now. So one of the issues, however, personally from my end, is that it still have Python dependency. So it's probably only good for people who's already using WasmEdge. So so you can use this together with your other application servers. But for people who's already using Python, it could be a difficult. It could be difficult to convince them to switch to using Wasm and Rust this way, right? So going forward, we will also have solutions that are completely not dependent on Python. Meaning that the encoder and decoder and things like that would be written in a lightweight or faster language that doesn't have that much dependency. For instance, in Rust, right? So that would allow us to do things that's very similar to our say Llama.cpp and Stable Diffusion Flux, and that type of plugins, where you can just install WasmEdge plugin without any external dependencies. So yeah, that's very much our roadmap, and hopefully, again, maybe we'll have the revisit of both demos next month. To have that's potentially a faster Stable Diffusion Flux, and then a faster or a stronger TTS demo. That we can connect them together with with large language model to build a complete application. Maybe that's something. Maybe we can have something more exciting to do next month. So anyway, so I guess that's it for all the talks that we have for this community meeting. And if you are watching this on the internet, that's where to find us. Just come to our GitHub repository, and if you have questions, issues, just raise the issue, and we'll see you there.